Good morning. Today we are going to study about common emitter configuration. So in common emitter configuration, emitter terminal is taken as the common terminal for both input as well as the output of the transistor. So here the input is applied between base and emitter, and the output is taken across collector and emitter. So here in the figure we are having both the transistors, that is NPN transistor and PNP transistors, and emitter is the common for both NPN as well as the PNP. So here this is the input junction and this is the output junction. So as in common base configuration, the emitter base junction is forward biased and the collector base junction is reverse biased. The electron flow is controlled as that of the common base junction, and the input current is the base current and the output current is called as the collector current. So next we are going to study about the current amplification factor beta. So beta is defined as the ratio of change in the collector current to the change in the base current. So it is called as the base current amplification factor. It is denoted by the symbol beta. And here the voltage across the collector and emitter is constant. Next we are going to derive the relation between the base beta and alpha, current amplification factor of common base and current amplification factor of common emitter. So beta is equal to IC divided by I, output current divided by input current. So from this we are deriving IB is equal to IC divided by beta. We know that alpha is equal to IC by IE. So from this we are forming the equation of IE, where IE is equal to IC by alpha. So we know that IE is equal to IB plus IC. This is the general equation. So we are substituting the value of IB and IE in this equation. So we are getting IC by alpha is equal to IC by beta plus IC. So in all the cases IC is common. So we are taking it out and cancelling it, we will get 1. So 1 by alpha is equal to 1 by beta plus 1. So take LCM on both sides. So you will get 1 by alpha is equal to 1 by beta, 1 plus beta divided by beta. So therefore alpha is equal to beta divided by 1 plus beta. We are rearranging this. So if you want the value of beta, cross multiply this, you will get alpha plus alpha beta is equal to beta. Whereas what is the value of alpha? So alpha is equal to beta minus alpha beta. So therefore beta is equal to alpha divided by 1 minus alpha. And here the alpha approaches unity and beta approaches infinity, since these two are inversely proportional to each other. Next, expression for collector current. So common emitter configuration, here the IB is acting as the input current and IC is the output current. So we are taking the general relation, IE is equal to IC plus IB. So from this IC is equal to alpha IE plus ICBO. So we know that IC is equal to alpha of IC. Instead of IE, I am substituting the value of IC plus IB. So next multiply the alpha inside. So you will get alpha IC minus, bring this alpha IC this side, so it becomes a negative factor. IC minus alpha IC is equal to alpha IB plus ICBO. So take IC as common, you will get 1 minus alpha, and next bring this 1 minus alpha to this side. So alpha divided by 1 minus alpha into IB plus ICBO divided by 1 minus alpha. So next configuration, that is characteristics of common emitter. So here the input resistance Ri is the ratio of change in the base emitter voltage to the change in the base current. Here VCE, that is the voltage across the collector emitter, is constant. And the output resistance represented by RO is equal to change in the voltage across collector and emitter to the ratio of delta IC, that is the change in the collector current, and here IB acts as the constant. Thank you.